Hello everyone, welcome back to the channel. In this video, we are going to discuss the problem titled Linked List Cycle 2, and that's numbered 142 on Leetcode. The question goes as, given a linked list, return the node where the cycle begins. If there is no cycle, return null. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Okay, initially the pause is used to denote the index of the node and the tail's next pointer is connected to. Note that pause is not passed in the parameter. Okay. Notice that you should not modify the linked list. Alright. So if we go ahead and look at the examples, we can see that we have a list 3, 2, 0, -4 and -4 pointing back to 2. So we can see that there is a cycle and the cycle starts at 2. So we probably need to return 2 here. So input is 3, 2, -0, -4, pos equals 1, and yeah, right. In the example 2, we can see that 1 points to 2 and 2 points back to 1, and the cycle starts at 1, right. In the third example, we can see that there is just one node which points to a null, there is no cycle, and we need to return null. Alright, so to discuss the solution to the problem, let's move over to nodes. Okay, going ahead with that, let's consider we have a list of this sort. And if we use our previous technique of finding whether there is a loop in it, we need to use two pointers. Let's name them C and S. When S reaches here, C would reach here. When S reaches here, C would reach here. When S reaches here, C would reach here. S reaches here, C would reach here. When S reaches here, C reaches here. Right. So this is the point where the two pointers meet. And this also proves that there is a cycle in the list. So yeah, I cleaned the thing up, and this is the list that we had, and marked with red is the point where the two pointers had meet. Let's consider the distance from here to here is some x, and the extra distance that they had to travel was some y. Okay, so we know that the fast pointer moved twice what the slow pointer did, right? So let's consider the slow pointer moved some n nodes, and n would be equal to x plus y plus he would have made some number of circles in the loop, right? So let's consider that to be I, and maybe the size of the loop is z, correct? And the second pointer would have made 2 steps, and that would also be equal to x plus y plus z, and the other pointer would have made some j number of cycles, right? Now if I want to use equation 1 and equation 2 together, I can substitute equation 1 into equation 2. So that would give me 2x plus y plus iz equals x plus y plus jz, right? If I have to simplify it further, it becomes 2x plus 2y plus 2iz equals x plus y plus jz. This becomes x plus y equals j minus 2i into z, right? So this is the main equation that we are concerned about. Now, if we look more into it, what this tells me is that, okay, so j and I are integers, right? So they basically were the number of times the pointers had moved in the loop. So since these are integers, I probably can replace it with some pz, where p also is an integer, right? So we know x plus y equals pz. This tells me that when I take some x plus y steps, the number of steps is actually equal to some multiple of the size of the loop. What I can now conclude is I can start from any point in the loop, let's say these points, and if I take x plus y steps, I will make some p cycles of the loop and come back and at the same point, right? Because I'm taking some p number of cycles. This p could be 1, this p could be 2, this p could be 3. If it is 1, if I take x plus y steps, I'll make one circle and come back at the same point. If it is 2, I'll make some two cycles and come back at the same point, right? If I move the y to the other side, x equals pz minus y. What this tells me is that if you start at any point in the loop and you take x steps, the pointer would make p number of cycles in the loop, but at the end it will fall short by y distance, right? So if I start at the point where the pointers had met, and if I take x number of steps, I will still be making p number of cycles, but this is where my p number of cycles end. But in the last cycle, I will fall short by y distance, right? So I'll end up somewhere here at this point, correct? And if I start from 0 and take x number of steps, if I start from here and I take x number of steps, I'll end up here. And that coincidentally is the point where the loop starts, correct? So the solution is basically once you find the point that the two pointers meet, this equation holds true, and if you take x number of steps from the beginning and x number of steps from the point that the two pointers had met, they will end up at the same point, and that point is the start of the loop. So we have two linked lists here, and using our method of finding whether the loop exists, we have found that the squared off nodes are the nodes where the two pointers meet. So considering the first list, let's find what number of steps do I need to take from the head to reach the point where the loop starts. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I take 9 steps, I reach this point, right? And according to our previous equation, I know that if I take 9 steps from the point where the two pointers had met, if I take 9 steps, I would make some integral value of circles around the loop and need to end up at the point where the loop starts, right? So let's take 9 steps from here. That would be 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So I ended up here. This holds true in this list. Let's also try this with the second list that I have here. I have found out that the two pointers will meet at this point using the previous method. Now, if I have to start from head, I need to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 steps to reach this point. And if I take 11 steps from here, what will happen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11. So I'll end up here. This is the point that that the loop starts. So we have found that this equation holds true, and we probably can go ahead and start the coding for this. So finally, to make this more clear, since we don't know x and we don't know y and we don't know any of the other variables, we don't know p as well, that how many circles would the second pointer make. So what the idea is, I'm taking x steps from the head to reach this point, and I'm taking x steps from the meeting point to reach this point, right? And if I take the steps simultaneously, let's start a pointer from the head and let's start a pointer from the meeting point. If I take one step each and I take a total of X number of steps, they will reach a point together, right? Because I'm moving one step at a time for each of the pointers. And once they meet, I know that is the point where they have covered equal distance and also have met, right? And when they meet, we can conclude that that point is the point where uh, the loop starts. So, to solve the problem, we are going to use Java. As discussed previously, what we need is we need a method to find whether there is a loop in the list, and if there is not, we need to return null. So let's have a method that returns list node uh, find meeting point, and that takes in a node called head, and we are going to do the same thing. We'll have a list node cap and list node sam, and while cap doesn't reach the end, cap is not equal to null, and then cap dot next is not equal to null. We are going to move cap by 2 times, which is cap dot next, and we are going to move sam by 1 space, sam dot next, right? And if we see that they meet each other, cap equal sam, we need to return that particular node, return cap. And if we don't find one, we return null. Cool. So we have a method that finds the list node where the two pointers would meet if there is a loop in it, and if it does not have a loop, then we return null. So in my main method, let's have a list node meeting point, which will fetch the meeting point from find meeting point, right? And I'll pass in head over there. If the meeting point is null, equal null, we return null. Yeah, and if it's not, then return find starting point, find starting point, and we pass in head and meeting point to this, right? So what I want is now is I need another method called list node, returns a list node find starting point, and that takes in a list node head and a list node meeting point. Okay, in this, what I need to do is list node uh, from head equals head, and list node from meet equals meeting point. While, and I need to do it until and unless I have both of the pointers meet each other. Okay, so from head, while from head is not equal to from meet, what I'm going to do is from head equals from head dot next, and from meet equals from meet dot next, right? And this loop would end when the two pointers to meet each other. And since they are in a loop, they have a cycle in the list, they would definitely meet. We will not end up in an infinite loop. and we need to return from head since they have already met. Yeah, so let's go ahead and try running this problem. Okay. Oh, so sorry about this. Cap would be at head, right? Okay, so yeah, this is the solution. It's faster than 100% of Java solutions online. Cool, thank you.